Welcome to section 6.1, day 2. This is slope fields. Slope fields are just a graph of the shape of the function using a differential equation. It has little small slope lines at each point. All right, so we're going to look at an example because it's a little bit easier to see through an example than it is to explain it in words, although I just used some words. All right, so we're going to look at this differential equation right here, dy dx equals x plus 1. And depending on what x is, we are going to define the derivative value. Okay, so I'm going to ignore the 3's because I don't even have room. Well, I guess I have room. Yeah, oh, I'm sorry, I do have room for all those. Okay, x equals -3 to positive 3. We're going to plug in all these numbers into this equation for x and see what we get. So if we put a -3 plus 1 in here, we get a -2. So we're basically adding 1 to each number, right? -2, -1, 0, 1, 2, 3, and 4. So these are the slope of the tangent line at each of those x values. Okay, so if I take a look at the first one, at -3, right here, this is where x equals -3, all up and down this line. All right, x equals -3. At each one of those points, our slope is equal to -2. So we're going to draw a little line with a slope of -2. Now, -2 is, and these are all best guess estimates of a slope line. Okay, so they're not perfect, it's just estimate of the slope. All right, at x equals -2, which is in this column, the slope is equal to -1. All right, so that's a 45-degree angle slope. At x equals -1, the slope is 0. So in this column, we have zeros. That is the slope, that's a little tangent line that has a slope of 0. These are each little mini tangent lines. All right, when we get to x equals 0, our little mini tangent line is going to be equal to a slope of 1, which is a 45-degree angle 1. Okay, now at 1, 2, and 3, our slope is going to get more and closer to vertical each time we draw it. So at x equals 1, let's draw a 2 slope. This is an estimate. A 3 slope. And then a 4 slope. It's hard to tell the 3's from the 4's. Okay, that is a slope field. You have created a slope field. Now, what does a slope field do? It actually gives us an idea of what the curve would look like depending on the initial value. So let's say this red pen is going to be my function, and it shows me that one solution of this differential equation might be a parabola that looks like that. Another solution might be a parabola that looks like this. It gives us kind of guidelines, if you will, for how our function would look. And let's take a look at using our differential equation, which is dy dx equals x plus 1. If we were to take the antiderivative of that, we find that the differential, or that the function equation is add 1 divided by 2 plus x plus c. Notice this is the general solution of this differential equation is a parabola. It all depends on what c is. So there are lots of different solutions for this differential equation. But a slope field is the grid with the little slope lines. Okay, let's do another one. This one's a little teeny more complicated because you have an x and a y in your equation. All right, so when you have an x and a y, you need to pick different points that help you find the slope. Now, some people make grids like this and do that. I'm going to just because it helps a little bit. If we have a 1 and a 1, we add them, 1 plus 1, we get a 2, right? If we have a 0 and a 1, we get a 1. If we have a 1 and a 0, we get a 1. So these are our slopes. Okay, if we have a 2 and a negative 1, and I don't have a real good pattern going on here, but a 2 and a negative 1 gives us a positive 1. All right, and then a negative 1 and a 2 gives us also a 1. If we have a negative 1 and positive 1, we get a 0. We have a negative 2 and a positive 2, we get a 0. All right, so let's start with some of these. Remember, this column right here is our slopes. All right, and these are our x and y coordinates. So let's start with 1, 1. 1, 1 is right here, and that slope is going to be 2. So we have kind of a straight or a more vertical slope. All right, we have all these are 1s at each of these points. 0, 1, 0, 1 is a positive 1 slope. 1, 0 is a positive 1 slope. 2, negative 1 is a positive 1 slope. Wow, I'm seeing a little pattern here. It looks like all these diagonals are positive 1. How about if we do a negative 1 plus 2, aha. Okay, those are all diagonals. Now I wonder if that works in every case. If we have this point right here, 2 plus 0, aha, we have a 2. So there are patterns in these, and it helps if you're able to find them. Negative 2, positive 2 is a 0 slope. Okay, so let's see, 0 and 2, that gives us a positive 2 slope. So these three right here are positive 2 slopes. The next row of diagonals, if you will, let me draw this, are all positive 1 slopes, right? Those are all positive 1s. Then this one is a 0. Negative 1 and 1, that's also a 0. And 0, 0 is a 0. And this is a 0, and this is a 0 when they're equal. Okay, so I'm kind of finding a pattern. Over here at, well, let's try negative 1, 0. Negative 1, 0 gives us a negative 1. Okay, so this is a negative 1 slope, 45-degree angle. This one down here is a negative 1 slope. This entire diagonal is negative 1. Okay, sweet. I bet this one is a negative 2, and it is a little bit steeper. Okay, and this one is a negative 3, because you're adding 2 negatives together. And these get more and more steep, and these are going to get 3s are right here. Well, actually, this one was a 2, but these are 3s, a 4, and a 5, which get more and more straight. So this general, or the shape of this curve, oh, I know, this one asks you to sketch the graph of a particular solution. Okay, I can't see the bottom down here. This one tells you to sketch the graph of a particular solution through the point 2, 0. So let's use our little red pen and make a mark on the point 2, 0. All right, and you use this as a sketch to make a diagram of what you think the function will look like. Okay, so this is a particular solution. I think we want to say particular function or particular solution through the point 2, 0. So I graph 2, 0, and I draw a little graph. It is a sketch. It is not perfect, but it gives you an idea of the shape of your function. Okay, last but not least, we have x times y. Again, these you're going to plug in numbers and do your best estimate of the function. All right, anytime x is 0 or y is 0, our function is going to be 0, right? -1, 0, +1, 0, 0, 1, 0, -1. So let's do all these zeros and see what that looks like. 0, 0 is a 0. 1, 0, that's a 0. That's a 0. That's a 0. Oh my goodness, everything on the two axes are going to be 0, right? Okay, what if we have 1 times 1? We get a 1. If we have -1 times -1, we get a 1. If we have 1 and -1, we get a -1. So let's try these two 1s here. 1, 1 gives us a 1, and -1, -1 gives us a 1. And then if we have this over here where we have a +1 and a -1, we get a negative slope, and we get a negative slope up here. Okay, let's try some more. How about if we have -2, -1? Now, anything in the first and third quadrants, when we multiply them together, are going to be positive slopes. So -2, -1 is a +2 slope. This is -1, -2, that's a +2 also. And 2, 1 is going to be a +2 and a +2. I'm seeing some mirror image activity between the quadrant 1 and the quadrant 3. Nice. Okay, so 2 times 2 gives us 4. These are very steep slopes up here. And these are very steep slopes down here. When you multiply -2 times -2, -3 times 1, that should be a 3 slope, and a -3 times -2. Wow, that's a -6 slope. So this one would be just a little bit less steep. It's a 3 instead of a 6, which is almost straight up and down. All right, so it looks like the same thing is going to happen between the fourth quadrant and the second quadrant, where we have mirror images. Okay, so 2 times a -1 gives you a -2 slope. 1 and -2 gives you also a -2 slope. -2 slope, -2 slope. All right, -2 times, or 2 times a -2 gives you a 4, -4 slope. And 2 times 2, this gives you a -4 slope. -3 times a -1 gives you a -3 slope, which is what we have down here, a -3 slope. And this is a big negative slope. So notice this is our cutesy little, let's see, I have written up here that this is page 325, example 8. So I'm not sure if that's true or not, but anyway, this is slope fields. All right, that's all I have for today. You have the worksheet and you'll have some other problems to do, but it's basically being able to create a slope field and also be able to sketch a function within that slope field if you have the information. All right, signing off. That's the end of section 1 in our chapter 6.